Have you seen some real-world phenomena that are a result of refraction of light? Let's start with a simple example. Consider a pencil which is kept at an angle and half submerged inside water. Let's look at this pencil from the side. It looks as if the pencil is broken inside the glass of water. Did it really break? No, the pencil didn't break. It only appears to be broken. And why does it appear so? Yes, it's due to refraction of light. To understand this better, let us look at the situation from the top view. The person observing the glass is looking at the side view of the glass and is at this point. This is the pencil and this is its image. The light from the pencil is incident here and then refracted like this. If we draw a dotted line backwards, it leads us to this image. So when we look at the image of the pencil, it appears as if the light rays are traveling to us from here. This in fact is a refracted light ray and it is refracted at the boundary. But wait a second, how many times is the light bending? Light is bending twice. First at the boundary of water and glass and second at the boundary of the glass and air. But the refraction from water to glass is minimal as the glass is not really thick. Hence we will ignore this tiny refraction. This is the reason why the pencil appears broken even though it's absolutely intact. Now let's make it more interesting. We insert oil in the glass. The oil will float on water as its physical density is less than that of water. What do we notice? The pencil appears to be broken into 3 pieces. What is the reason for this? Can you guess? It's because light bends more in oil than in water. Let me explain it in detail. There are 2 cases here. One, refraction of light when it travels from water to air. And second, refraction of light when it travels from oil to air. We draw a simple ray diagram to represent the situation. Let's discuss the first case. We know that light is getting refracted at the boundary of water and air and is then reaching our eyes. And air is optically rarer than water. Hence, light bends away from the normal. Similarly, in the second case of oil to air, light is traveling from an optically denser to an optically rarer medium. Hence, it also bends away from the normal. And here's the interesting part. Since oil is more optically denser than water, light bends further away from the normal in this case. Or we can also say that air is more optically rarer than oil than it is to water. And this is the reason why the portion of the pencil inside the oil appears further apart from the actual position than the portion inside the water. The light bends more when traveling from oil to air than it does from water to air. And the simple reason is because the optical density of oil is more than that of water. Some of us may have another doubt. Even though the water is more physically denser than oil, its optical density is lesser than it. Yes, there is a difference between optical density and physical density. We have seen in our previous videos what optical density is, and we must have studied physical density many times in the past. Optical density is the extent to which the medium bends the light, whereas physical density is simply the mass over volume ratio. A medium with lesser physical density in comparison to another medium can be optically denser than the other and vice versa. A perfect example here is that of water, which is physically denser than oil but is optically rarer than it. There is another fun experiment that you can try at home. Take a coin and put it in an empty container. Keep going backwards and adjust your position in such a way that the coin just disappears from your sight. Now pour any transparent substance, say water, into the container. Did the coin reappear even though your position is unchanged? Yes, and this is due to the refraction of light. The light bends and reaches our eyes.